Hello friends, welcome to the video lecture series of engineering mathematics. In this video, we are going to discuss the Fourier Transform. Basically, the Fourier Transform is the extension of Fourier series. In last year, you have gone through Fourier series. Fourier series is used when we want to express periodic and complicated function in terms of simple function like sine function and cos function, where Fourier series is used. In Fourier series, function must be periodic. Yes, what is periodic function? The periodic function exhibit regularly repetitive pattern. That is what the periodic function. But if the functions are not periodic, in that case, we apply Fourier transform. Fourier transform is highly used in mechanical vibration. It is also used in bending of beams. Mainly, the engineering application of Fourier transform at undergraduate level is to solve the partial differential equation and in circuit analysis. So we find the applications of Fourier transform in electronics engineering also, especially in signal processing. It's one of the important applications of Fourier transform. When the analysis of the signal is required, the time domain signals are transformed into frequency domain signals, then it becomes simple for analysis. In this lecture, I'll tell you how the Fourier transform works. There's some problems on Fourier transform. So we start with the definition of Fourier transform. It's Fourier transform of fx, function fx, is the integral minus infinity to infinity fx e power minus I lambda x dx. Here, limits of integrations are minus infinity to infinity. Once you take the integration of this, the x will disappear and only lambda will remain. So after integration, you will be getting lambda function only. The Fourier transform of x function is a lambda function. The Fourier transform of fx is f lambda. In that way, Fourier inverse transform of f lambda also we have defined. What is the inverse Fourier transform of f lambda? Is 1 by 2 pi minus infinity to infinity f lambda e to the power I lambda x d lambda. Which we are integrating this function with respect to lambda. Here we are integrating the function with respect to x. Once you integrate it, only x function will remain. Fourier inverse of f lambda is fx. Fourier of fx is f lambda. Now some short answer questions on Fourier transform. Find Fourier transform of fx, where fx is defined in this way. The fx is 1 for this interval and fx is 0 for this interval. So we are interested in the value of fx which is non-zero, because for 0 value the integral will be 0, so it will not have any use here mathematically. So fx equal to 1 for mod x less than a. What is the definition of Fourier transform? Fourier transform of fx is minus infinity to infinity fx e to the power minus I lambda x, and we are integrating with respect to this. Here I have to put minus infinity to infinity in order to reduce steps. The mod x is less than a means mod x is less than a means x lies between minus a and a. So here I am writing minus a to a because for other part of the interval the value of fx is 0. So what is value of fx here? Minus a to a, fx is 1 for this way, e to the power minus I lambda x. Take integration of e to the power minus I lambda x, which is e to the power minus I lambda x by minus I lambda, because lambda is constant and I is also constant, only x is variable. Minus a per limit and per limit, minus 1 by I lambda. Put x equals, we have x is variable here. Put x equals a, e to the power minus I lambda a minus e to the power I lambda a, this minus will be plus, and this can be written as e to the power minus I theta minus e to the power I theta is 2 times sine of theta with negative sign. So this formula I am going to use, and one more step I am going to solve, and this formula I am going to use. So it is minus 2 sine of lambda a e to the power minus I theta minus e power I theta equals 2I sine theta with negative sign, minus 2I sine theta. Here, this can be replaced by minus 2I sine of lambda a, and this minus will be plus, and 2 sine lambda a, this divided by lambda Fourier transform of this unit step signal is 2 sine lambda a by lambda. Now, coming to the next one, Fourier transform of fx hyper. Here we have 1, here we have x. The procedure is same. The Fourier transform of fx, integral minus infinity to infinity, e to the power minus I lambda x is. Here x lies between minus 1 and 1, here I am putting minus 1 and 1. Is for other part of the interval, value of fx is 0, no need to write. The minus 1 to 1, fx is x here, and e power minus I lambda x is. In examination, this x may be replaced by x by 2, x may be replaced by 2x, x may be replaced by any other variable. Now, use by part and get the value. Here, I am using by part first function, integral of second function. This integral I am writing in the bracket, minus derivative of first function, minus derivative of x is 1. The generalized by part I am using, and integration of this bracket completely, e to the power minus I lambda x, its integration is e to the power minus I lambda x divided by minus I lambda. The minus I lambda is already there. Now I am going to solve for one more step. This x e power minus I lambda x by minus I lambda as it is. This minus I lambda into minus I lambda. It will be what? Plus I square lambda. The I square lambda, I square is minus 1, means minus lambda. So this minus as it is, e to the power minus I lambda x by lambda with negative sign. Is it? This minus is as it is, and product of this is minus lambda. This minus and this minus will be plus later on. Now, put upper limit and lower limit. Put x equal to 1, I am putting x equal to 1 like this. This minus is plus. X equal to 1, I am putting minus minus plus. X equal to 1, I am putting minus. Put x equals minus 1, x equals minus 1, I am putting minus 1, this minus will be plus. This divided by minus I lambda minus. This minus plus. Put x equal to minus 1 e to the power I lambda. X is minus 1, minus will be plus, and this minus is plus already by lambda. E to the power minus I lambda by minus I lambda plus e to the power minus I lambda by lambda minus 3 times here, minus of e to the power I lambda by I lambda, and minus of minus plus is minus e to the power I lambda by lambda. Is it? Then now in the next step, you can combine these two. You may combine these two, and you can use this formula, e to the power I theta minus e to the power minus I theta by 2I sine theta. This formula you can use, or e to the power I theta plus e to the power minus I theta is 2 cos theta. Use these two formulae and write on the last step. Okay, I am not writing here last step because we don't have space here. So use this formula and write on the next step. Now Fourier transform of this function. Here see Fourier transform of x for this range, Fourier transform of 1 for this range, Fourier transform of 1 minus x square. In place of 1 minus x square, you will be given x square also or any other variables. Now use definition of Fourier transform and try to solve it, and this is for you. This will be the Fourier transform of this function. Okay, but this is a long answer question. This is not short answer question. No? But for practice, you can solve this problem. The answer I have given. Next problem. The Fourier transform of fx, here minus infinity to infinity, fx e to the power minus I lambda x dx. This is the definition. Limits minus infinity to infinity. But for non-zero value of fx appears for minus pi to pi. Here I am writing minus pi to pi. The fx is pi by 2 cos x e to the power minus I lambda x. So for sake of simplicity, what I am going to do? I am going to write e to the power, I am going to use this formula, e power I theta is cos theta e to the power minus I theta is cos theta minus I sin. The e to the power minus I lambda x is cos of lambda x minus I sin lambda x. This exponential function I have written the sine and cos is for the sake of integration. This pi by 2 is multiplicative constant, you can take it outside. Minus pi to pi cos x into cos lambda x dx I am going to distribute. Then pi by 2 is outside. Minus as it is here, integral minus pi to pi cos x multiplied by sin lambda x. This minus I am writing here. I is constant. Now, integration of any function gx or minus a to a is 0. When gx is odd, the property of definite integral I am using. If integral minus a to a of fx, integral of this is 2 times 0 to a, this is 0. When fx is even function. Here, this cos x, this cos lambda x, this is even function. This is even, this is odd, product of odd and even function is odd function. So this is odd function now, complete. The integral of odd function between minus a to a, minus pi to pi will be 0. This value of this will be 0 directly. Now, pi by 2. This minus 5, this is even function. Cos is even, this cos is even, product of even is even. But 2 times 0 to pi, I am using this property of definite integral. Cos x into cos lambda x. Now, this 2 gets cancelled, pi is there, integral 0 to pi. Cos a into cos b formula you can use. What is cos a into cos b formula? It's 1 by 2. Cos of a plus b, x plus lambda x plus lambda x plus cos of a minus b, cos of x minus lambda x. Directly I am writing. Now, integral, this is pi by 2, integral of cos is sine 1 plus lambda x by 1 plus lambda. Integral of this is sine 1 minus lambda x by 1 minus lambda. Lower limit is 0 and upper limit is pi. Now put upper limit and lower limit, so you will be getting this answer. Put x equal to pi, put x equal to 0. If you put x equal to 0, the sine 0 is 0. And if you put x equal to pi, then this final answer you will be getting. So here, you may do like this also. Sine of 1 plus lambda pi. Sine of 1 plus lambda pi is sine of pi plus lambda pi. And sine of pi plus theta is minus of sine theta. Sine of pi plus theta is minus of sine theta. So this can be written as minus of sine lambda pi. Sine 1 plus lambda pi can be written as like this. And sine of 1 minus lambda pi, again you can write in this way. Sine 1 minus lambda pi is sine of pi minus lambda pi minus for sine of lambda pi. Sine of pi minus theta is sine pi theta in minus sine pi plus theta is minus sine theta. Sine pi minus theta is plus sine theta. In that way you can use it. In that way you can use this thing to find out the value of Fourier transform of this. Okay, you try to solve this and you will get this answer. Now Fourier sine transform. Fourier sine transform is different in this way. Fourier sine transform of fx is 0 to infinity, fx sine lambda x dx. The Fourier sine transform of fx we want. The Fourier sine transform of fx is written like this: integral 0 to infinity fx sine lambda x dx. I am writing directly. So here the fx is non-zero means a. Fx is non-zero means a for this range. Therefore I am writing 0 to 1 here instead of writing 0 to infinity, because for other intervals fx is 0. Now 0 to 1 fx is a. Now take integration of sine. Integration of sine a is outside. Integral of sine is minus of cos lambda x by lambda. Lambda is also I am writing outside. Lower limit is 0, upper limit is 1. Minus a by lambda as it is. Put x equal to 1, cos of lambda. Minus put x equal to 0, cos 0 is 1. In this way, the Fourier sine transform of fx we found. In examination, this a may be replaced by any other constant, 1, 2, 3, 4, 5, like that. Now, Fourier sine transform of fx for k greater than or equal to 0 and x greater than. Is k greater than 0 for x greater than 0 is x varies from 0 to infinity. Starts from 0 and is extending up to infinity. Fourier sine transform of fx I am writing integral 0 to infinity, because x is defined for 0 to infinity. Here x was in between 0 to 1. Here x is greater than 0 and it extending up to infinity means x varies from 0 to infinity. Fx. What is fx given to you? Then sine of lambda x. So this integral will come. So in order to evaluate this integral, I would recommend you to use this formula directly. 0 to infinity e to the power minus ax sin bx is b by a square plus b square. Here our a is k and b is lambda. Therefore, the integration of this is lambda divided by a square plus b square. In a single step, we have solved this problem. Fourier sine transform of e to the power minus kx. In examination, this k may be replaced by any other fixed constant. This k may be replaced by 1, 2, 3, 4, 5 and so on. Even fraction also. Now, Fourier sine transform of fx for e to the power minus mod x for 0 less than x less than infinity. As all of us know that mod of x is positive. Mod of x is positive for x greater than 0. For x greater than 0, mod of x is positive. Or this can be written in this way also. Fourier sine transform of fx is e to the power minus x for this range. For x lies between 0 to infinity. Means for x greater than 0, mod of x is x. I want Fourier sine transform of fx. What is the formula? 0 to infinity. Function is e to the power minus x and sine of lambda x. Now use this formula again. E to the power minus ax. A is 1, b is lambda. Therefore, using this formula, b divided by a square plus b square is lambda by lambda square plus 1 is Fourier sine transform of this function. Now the Fourier sine transform of this function. The Fourier sine transform of this function for this range. Because x is defined for 0 to 5. Okay, this given range is important. The Fourier sine transform of fx is integral fx sin lambda x. The fx has a non-zero value sin x for 0 to pi. Only I am writing 0 to pi. Okay, this I am going to do only to reduce the steps only. Now fx is sine of x, that is given to you for this range. Sine of lambda x is as it is. Now integrate it. The sin a into sin b formula, this I have written here. I am directly writing 1 by 2 cos of a minus b, x minus lambda x minus lambda x, minus cos of a plus b, x plus lambda x plus lambda x. Now integrate 1 by 2 is outside. Integration of cos is sine 1 minus lambda x by 1 minus lambda. Integration of this is sine 1 plus lambda x by 1 plus lambda. Lower limit is 0 and upper limit is pi. So if you put x equal to 0, the sine 0 will be 0. Put upper limit and lower limit. What I am going to do? 1 by 2 sine of 1 minus lambda pi by 1 minus lambda minus sine of 1 plus lambda pi by 1 plus lambda. And if you put x equal to 0, sine 0 is 0 and this will be 0. So I am writing 0 here for x equal to 0. Sine 0 is 0 and this sine 0 will be 0. Now 1 by 2. Yes, as we have done earlier, sine 1 minus lambda pi can be written as sine 1 minus lambda pi, means pi minus lambda pi can be written as sine of lambda pi. Sine pi minus theta is sine of theta. Here I am writing sine of lambda pi by 1 minus lambda, and sine 1 plus lambda pi is minus of sine lambda pi. After that, you can take sine lambda pi common, 1 by 2 sine lambda pi I am taking common, and 1 by 1 minus lambda, minus minus plus 1 by 1 plus lambda. Okay, this is Fourier sine transform of this function. So you may increase one more step. The last step I am going to write here. The Fourier sine transform of fx equals sine lambda pi as it is, this 2 is as it is, and take LCM 1 minus lambda, 1 plus lambda. Product of two denominator is LCM here, and have a cross multiplication, then 2 will be there. 1 plus lambda and 1 minus lambda. Lambda will get cancelled and 2 will be there. These 2 gets cancelled. Then sine lambda pi by 1 a minus b into a plus b, 1 square minus lambda square. So this is Fourier sine transform of fx we found. Now similarly, the Fourier sine transform of cos x here to find. Use this procedure and find Fourier sine transform of fx. Only the difference is here we have sine and here we have cos. Then when we evaluate integration, we use this formula to evaluate integration. For 3-4 steps, you will get Fourier sine transform of fx. Now, Fourier cosine transform. Fourier cosine transform of fx is defined as Fourier sine transform and Fourier cosine transform. What is the difference? In Fourier sine transform, here we have sine. In Fourier cosine transform, we have cos. The same thing we have to do. For cosine transform of fx 0 to 2, because for 0 to 2 we have non-zero fx, and fx, this fx I am writing, and cos lambda x. I am putting value directly. A is outside, A is constant. Integration of cos is sine lambda x by lambda. X is variable. Now, a by lambda, put x equal to upper limit sine 2 lambda minus put x equal to 0, sine 0 is 0. Means sine 2 lambda multiplied by a by lambda is the Fourier transform of this one. In examination, a may be replaced by any other fixed constant. Now the same thing here, as we have done in Fourier sine transform. Fourier cosine transform of fx is 0 to infinity. Here x varies from 0 to x is greater than 0 means x varies from 0 to infinity. Fx cos lambda x dx. Now, in order to evaluate this integral, use this formula directly. Here a is k and b is lambda. The a by a square plus b square, a by a square plus b square. In a single step, we found Fourier cosine transform of this function. In examination, k may be replaced by any other fixed constant. Again the same thing. Here Fourier cosine transform of this function for x greater than 0 up to infinity. The mod x is x. Therefore, this question will be asked like this also. Okay, these two carries the same meaning. Fourier cosine transform of fx is integral 0 to infinity. Fx is what? This one. These two are same because mod x is x for 0 to infinity. Cos lambda x dx. Use this formula. Here a is 1 and b is lambda. Therefore, by this formula, a divided by a square plus b square is 1 by 1 plus lambda square is the Fourier cosine transform of this. Here Fourier cosine transform of sin x now limits 0 to pi and fx has a non-zero value. Here I am writing 0 to pi directly. Fx I am writing directly for this range. Cos of lambda x dx. Fourier cosine transform. Now sin a cos b formula to use. What is sin a cos b formula? Sin a cos b formula is 1 by 2 sin of a plus b plus sin a minus b divided by 2. This is sin of a into sin b formula. Sin a sin b is 1 by 2 sin a plus b plus sin a minus b. Now take integration. Integral of this thing is just one more step I am going to write. Sin 1 plus lambda x, or you can write it directly also. So one more step only I have increased. Before integration, I have taken x common 1 by 2. Integral of sin is minus cos 1 plus lambda x divided by coefficient of x is 1 plus lambda. Integration of sin is minus cos 1 minus lambda x divided by its coefficient, or you can say the derivative of the argument also. Derivative of 1 minus lambda x is 1 minus lambda, 0 to pi. The minus sign you can take outside before putting the limit cos of 1 plus lambda x by 1 plus lambda plus cos of 1 minus lambda x by 1 minus lambda. Now put x equal to pi and x equal to 0. If you put x equal to pi, what will you get? Cos of 1 plus lambda pi by 1 plus lambda, cos of 1 minus lambda pi by 1 minus lambda. Put x equal to upper limit. Now put x equal to lower limit. If you put x equal to 0, the cos 0 is 1. Cos 0 is 1. The cos of 0 is 1. 1 by 1 plus lambda plus 1 by 1 minus. So this is Fourier cosine transform of sin x. So you can resolve this later on. Cos of a plus b or cos of pi plus theta is minus cos theta. Cos of pi minus theta is again minus cos theta. In that way you can solve it for 2 more steps, but those steps for you. Now Fourier cosine transform of cos x. Only 2 steps I am initiating this, and rest of the part will be for you. Fourier cosine transform of fx is integral 0 to pi fx. For this range, value of fx is positive. Cos lambda x dx. Use cos a into cos b formula, then integrate it, followed by putting the limits and get the answer. Okay, this solution is for you. Now the solution of integral equation. The integral equation is given. You have to solve this integral equation. Solving integral equation is to find out value of fx. These are the typical integral equations where the Fourier cosine transform, Fourier sine transform can be used. This is given As per the definition of Fourier cosine transform, integral 0 to infinity fx cos lambda x dx is Fourier cosine transform of fx. By definition of Fourier cosine transform, by definition, this can be written as like this, and e to the power minus lambda is there on the right hand side. As we want the value of fx, what I do, I am shifting this fc on the right hand side. It will be fc inverse. Fc inverse means inverse Fourier cosine transform. Now, by definition of inverse Fourier cosine transform, this is the definition of inverse Fourier cosine transform. 2 by pi 0 to infinity f of lambda is this function for which we are finding inverse Fourier cosine transform, cos of lambda x dx. Now, in order to integrate it, use the same formula, e to the power minus a lambda cos of b lambda. Its integral between 0 to infinity is what? A divided by, a is 1, a divided by a square plus b square. Here b is x now, because our variable is here, which should be lambda, p lambda. Inverse Fourier cosine transform, lambda is the variable of integration. In Fourier cosine transform, x is the variable. Therefore, this one we have used 0 to infinity e to the power minus of a lambda cos of b lambda. This is equal to a by a square plus b square. This formula we have used to have the integration. Okay, this is the value of fx. We have solved this integral equation and we got the value of fx. The same thing. Fourier, if you look at this left hand side, it is by definition, it is Fourier sine transform of fx e to the power minus lambda. I want value of fx because we are solving this integral equation. Shift this fs on the right hand side, it will be fs inverse, and fs inverse is inverse Fourier sine transform. And by definition of inverse Fourier sine transform, 2 by pi. Only replace cos by sine in inverse Fourier sine transform. 0 to infinity. F lambda is the function. Sine lambda x as it is. Inverse Fourier sine transform. How do you get integral? You use this formula directly. E to the power minus a lambda sine of b lambda p by a square plus b square. This formula you can directly use to have the integration. 2 by pi p divided by. This should be lambda. Here this is lambda, here this is lambda. X divided by p divided by a square. A is 1. So this is the value of fx. Now the solution of an integral equation. Again, the value of fx I have to find. This can be written as Fourier cosine transform of fx. Right hand side is 1 minus lambda for 0 less than or equal to lambda less than 1 or equal to 1. This I have not written because mathematically it is going to become 0. The value of this integral is going to become 0. Therefore, it will not play a role analytically. That's why I am not putting it there. Is it? Fx equals inverse Fourier cosine transform of 1 minus lambda. Now, by definition of inverse Fourier cosine transform, 2 by pi 0 to infinity f lambda is a function cos of lambda x dx. Now 2 by pi. Take integration of this using by part. Here one more thing I have to write. It should be in the next step. Here I am adding one more step. It will be 0 to 1. Okay, here you have to write 0 to 1 because the function value of the function is 1 minus lambda for 0 to 1, and for rest of the part of the interval it will be 0. Now use by part. We are integrating with respect to lambda. This is lambda because every time by mistake I am writing x in inverse Fourier cosine transform. the lambda is variable of use integration by part. Lambda is variable, other than lambda means x is constant. Cos function integral of cos lambda x sin lambda x with respect to lambda,
x is constant, minus derivative of 1 minus lambda with respect to lambda is minus 1. Integral of this is minus cos lambda x by x. X is already there, means x square. Lower limit is 0 and upper limit is 1. Next step, 2 by pi. Put lambda equal to 1. If you put lambda equal to 1, the 1 minus 1 will be 0. And if you put lambda equal to 0, then sin 0 will be 0. Means for lambda equal to 1, this term is going to become 0. For lambda equal to 0, this term is going to become 0. Means this will be cancelled out. So minus 3 times, minus I am writing here, cos lambda x by x square or 0 to 1. Minus 2 by pi x square. X is constant, lambda is variable of integration. Remember, put lambda equal to 1 cos of x only, minus put lambda equal to 0 cos 0 is 1. This is value of fx or solution of this integral equation. And this problem is for you. Here we have cos, here we have sine. This is for you. And the value of fx answer also I have. This is the answer to this one. The value of fx is this one. Solve the following integral equation. How do you do it? How do you find out the value of fx? By definition of Fourier Sine transform of fx, this left hand side is this one, and in this way 1, 3, 0, 0 less than lambda less than 1, then 1 less than lambda less than or equal to 3, and lambda is greater than 3. Okay, this is not of any limits. This one is not of any limits because this has a 0 value. Now, value of fx is Fourier sine inverse of this thing. Fourier sine inverse of this one. Is it? So this is represented by this one. Then f of lambda. Now, Fourier sine inverse is 2 by pi integral 0 to infinity f lambda sin lambda x t lambda. Fourier sine inverse of f lambda. But how the f lambda is defined? See, f lambda is defined for 0 to 1, for 0 to 1, for 1 to 3, for 3 to infinity it is 0, no need to write. Then integration f of lambda sin lambda x f of lambda sin lambda x. Now put respective values of f lambda. For 0 to 1, value of f lambda is 1, sin lambda x as it is. For 1 to 3, this is 3 sin lambda x d lambda. Now take integration of this cos of lambda x by x with respect to lambda. I am taking integration. 3 is constant. Minus I am writing here. Integral of sine is minus cos lambda x by x. Lower limit is 1 and upper limit is 3. Take minus outside. Here put lambda equal to 0 and lambda equal to 1. And put here lambda equal to 1 and lambda equal to 3. Okay, that is last step for you. Then that will be the final value of fx. In this way, we solved integral equation. We found value of fx. So we stop here. Thank you very much.